Nice to meet you to this new episode of Weekbeat. You can remember the CD player Azur 340C from Cambridge Audio runs well at the first second, and after a minute the spinner running in the wrong direction. So, well, I repaired the black one model, and under this hood, this metal thing, it's a IC, and this IC controlling the motor. It's a H-bridge, called like H-bridge. There are 4 transistors built in, and these 4 transistors must change the H-bridge in case of that it's under here, under the hood, under this. I think it's dying on long running times and it's a thermal fail from the IC. Cambridge Audio can do nothing in the construction for it. Also in the TIAC drive we have the same issue, and I think it's cool. We must build it out. Unbelievable. I disconnected here and here the drive, and we also must disconnect it here and 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 here. All these connectors we must disconnect. Yes. And then we lift up this board, also here. Let's disconnect this connector. This is the audio out. Look, here's the audio out. It's also for the back running wave. Here, it's not isolation, but it's a ferrite. They don't like to have that other waves coming from outside to the inside and from the inside to the outside of this grounding cable here around of the shielded cable. We must come under this black hood, and we disconnect first this. It's soldered on my soldering iron. It's not so easy to get out, but I must build it out. For this I must disconnect all this and that, and now we can move it out with disassembly it. Oh, my screwdrivers is gone out here. First we clamp this black things. I hope so there is no screw anymore. With this. Look, it comes now a little bit more out. And this. Snap. And here. You must also do this snappy. It's a plastic part. I don't know, here they make a screw and they make a plastic part. So, now we have it out, not right now. But here we must disconnect it and disconnect it. And what's here? We must desolder it. You can see that, wonderful. Oh, you need a strong so now we have it out. Look, wonderful, a wonderful Cambridge designed audio board, and I think so. This is the digital analog. This is the digital analog IC. Really, this is the duck. It's no joke. This is stereo duck. Yeah. I don't understand why they do this in that way. So I changed the table. I must heavy load. Here we are. We have here now the Cambridge audio board. Super. It's aluminum. Yes. And we must desolder it here on the corners. Oh, that was hot. Also not checking this, okay. And here we must bend a little bit this thing, but we must go under the hood, under this black thing. We must bend it a little bit. Look here. So we bend it. Okay, super. And here, I don't understand why they're doing this here. This black thing. It's in my eyes not necessary. In case of the electronic, they're doing the processing is here and here. The one is the controller. I don't know which one is the one is the controller of this board, and one is the digital processing from the disk, and here is the digital analog converter, and it's outside of this black box. Okay, but what is inside? Only the motor controller. Maybe this disturbing, but they are on one print, and yeah. That's not so cool construction. Also to bring the data to the converter from the back here. Here's the data output from the digital processing from these two parts. One is the controller for the software, firmware. The other one is the, I think you cannot read what is written on it. Maybe is this the processing, and this is the controller. But the funny thing is that the data came out here and will be transported over the whole board here to this place, and then here we have the connector, and then inside this IC, and this IC is the digital analog converter, and it's outside of the board, and the motor controller is here. I mean, from here to here you have some yeah. This IC we would like to change. We got a super instrument from China. Where is my super instrument? This is one of the interesting things in the world. Look at this. This is a pump and a soldering iron in one. This is the funny thing. We're doing a little bit with the, that you can see the pump. Super, huh? And I connect it to my current. I mean, the connector is they don't have any idea of security. They don't isolate it here. I mean, it's dangerous. So we must wait that the pump will load up, and then we are desoldering this. This is special made with this blue and for this blueprint. Special made for this building out. Now we would like to make a test with this special tool. Yes. Super. Look. Super. Zack. it's excellent now. It's not so, it's good, but I mean, come on. I must desolder it with the other iron, so it's more for big ICs and with a big distance from the pin distance must be big. So we must desolder it now here like this. It's more stupid, but no chance. I desolder it with this. I think I solder it first with normal solder to pick it up from the old solder. It's better than this. It's more efficient if I desolder it with a new solder. And so I think it's good. It's good. We using this, and I must build it out now, and the case will be here. It's not so easy to messing it out. I don't would like to touch it in case of look here is a, we must put here a paste, this terminal compound paste. Yep, this is very important for the next IC and the running time. It should be hold long. I mean that the user have lot happiness with it, and it's from Toshiba, this IC. It comes out. Here we are. We have the IC built out, and this is a TA2092NG. It's interesting. And from Toshiba I have the original from an old stock made in China, and I must search this IC, and in case of now we must clean that first. We should clean it. It's clean enough, I think. There is one solder point that is not so fine. We do this and desolder it. Super. Also, if you're using this copper desoldering tool, cut it off. In case of that, if the old solder is inside, you cannot do this. Oh, someone is. Look at this. We must clean it up, and we build it in. And the funny thing is, will not go in. Oh, and it's brand hot. So, look, and now we are starting to, I'll make a zoom, and now we starting to solder it in. First do that on the corner, the pins, and then Zack, one side, and the other side is now soldered in. Look at this, there is a short, then the other, I remember, it would not start. And now we are gonna to put that compound on it. It's very important to do this. In case of that, the next one will play for a long time. I would like to have it that this is running for a long time. In case of that, we're doing not only recycling, we would like to hold up the runtime high and long, so the user can play with this super audio player, this Cambridge Audio Azur 340. This is at, you must know, this is a 24-bit digital analog converter, I remember, and it's really cool. It's a cool machine. I like this. It remembers me on Mr. Clive Sinclair. This design. It's minimalistic, and this minimalistic design, it's super. Look, and we press it hard in, and now we solder it here. On each corner. You see? This is important. This is the cooling system. It's good. I think it's good. Look. No short on the pins. This is important. At the last time I make a short on 2 pins, and I only have one IC and don't found the other. That was my problem, my issue. And now we are going to see what we can do for it. Shall we close it? Yeah, we can close it. We can close the deck in case of there's nothing to do anymore here, and we can close the deck. We do that in case of yeah, we can run a test, but now the H-bridge is running, I think. So 1 and 2 and 3. Don't touch the electrolytical capacitors and press these down. Will be good. Oops. I'm talking about and doing this now. So. And here we are closing the can. I hope so. It's isolated. I don't think so. It's isolated. It's more a funny thing. Digital comes here out, but the digital is not disturbing anything. So we build it in and make a test. Now I would like to build it in, and can we connect this first in case of this should be good connected. All the interfaces must be connected. Don't know what this is. Control or power supply and so on. This should be good. Should be good connected. this is here, and this is here, and here is nothing. See, nein, I must have a watch on this, where it is. For what is this? And this is here. I remember this was here. And micro. What is micro? Funny. Some dirt inside, huh? Oh, okay, I see. I see this connector. This must be here. Put this in here. And now we connect the drive to it and the laser division. Laser here. I hope so. This is working. Okay, looks good. Looks good, and now we have the thing that we would like to build it in. Oops. It should be on this plasticky thing, and I hope so under it, under the thingy. Yeah, it should be. It's so. I mean, now we have the point. Here we have the point. I don't would like to. This ground we should also solder on, but okay, we make a little spin up. Now we need to have the power supply. Okay, and blue light is coming. And now we must turn it on, out, and searching a CD. We take the audio and tones CD from Weakbit. Here is audio and tones, and we close this door. And yes, it spins up. Cool, and play. Oh my gosh, that was a historic thing. I think these ICs will go every time defect on this Toshiba, IC manufacturer. But a long time this CD player is long on the market, so we must know to putting a tape and switching on, and now it's audio cable is on, click, and no audio. Interest, why? Here is the audio over the speaker. Super. Yes, baby, yes. Cambridge Audio, one of the best in the world. Super, bravo, I like my player. What do you say to this win-win-win situation? So, we stop it now, put the CD out, close the deck and disconnect it from the mains, and we are disconnected also from here. We click in the board is now clicked in, you can see, and then we make a screw on it. This is this screw that holds the print here in position. Super. Okay, some. And we must solder also this but I hold this with the pliers. It's better for me, for my fingers. I remember the last time where I do this was not so funny. You can see that it's not so much action, and we doing the next step. We clean out this a little bit, and it must be, in case of I would like to have the dust inside. Okay, super. This is good, and now we close the body and putting the machine back in position, and super. It's wonderful build. You must know it's a wonderful machine, and I like it very much, this Cambridge Audio. In case of that, simple to repair. Not only that, I mean the sound volume, yeah, from this 8-pin IC, it's great. You must listen this on a good speakers, and this is a super thing. Now I must build in these little tiny screws with the Torxy, you see, and I must close the deck. Now it runs well, the machine, and you listen to my speakers. Oh, it's wonderful. Now the Cambridge Audio Azur 340 have his second life and will run the next 10-20 years without problems. And if this IC not on the market anymore, you can buy it. That was the Azur 340C from Cambridge Audio, and well, the IC from Toshiba, the H-bridge, will give up now the second time. I repaired first a black one model from the same 340C, and now I repair this silver model, and you hear it runs well and the sound is excellent. Also this 8-pin IC with the 24-bit converter is excellent. This is a masterpiece of technology.
in this age. Now I think so it's running the next 10 years or 10-15 years, how old it is now, and then it's burned out again. But the H-bridge will be give also in the future. The TA292N from Toshiba was not the worstest. It's a defect, like a car can be also going defect in 15 years or 20 years. I don't know how old this machine is. If you're interested in my channel, please subscribe and or sponsor me at Patrons. And I say thank you for watching.